So the first thing we have to do is discuss what's a quadratic? How do we know it's quadratic? The x variable has a 2 as its exponent. So out of the entire equation, the biggest exponent you see is the number 2. Have we seen them before? Yes. Library of functions. We know that's a quadratic equation because there's a square. It's a 2 on there. Because it's a 2, what does it tell us about our graph? Okay, we know the graph is a parabola, but what does it tell us about our graph?
That is decreasing 0 and increasing infinity.
Right. On the left-hand side, well, on this case, yes. But I can also have, that's also a quadratic. So what you said there is correct. There's one side it's increasing, one side is decreasing. They're opposite slopes of both sides. What it tells us is that both ends point in the same direction. That's what it tells us. If it's quadratic, both ends point the same direction. Now, since it's quadratic, it also has what's called a vertex. The vertex is the highest or lowest point on the graph. So is this one the highest or lowest point on this one? This one? Now, there are Latin names we give them. If it's the lowest, we call it the minimum. The lowest point is called the minimum. The highest point is called the maximum. The plural of those in Latin, the plural of, anybody know what the plural of minimum is? Minima. The plural of maximum? Maxima. If you have multiple vertices. Can we have multiple vertices? Do we know any functions that have multiple vertices? Yeah. The cubic function has how many vertices? Right. It has these points as vertices. I know I'm going ahead of myself, but since we're talking about these things, since the quadratic only has one vertex, the cubic has 2 vertices. Do we see a pattern here? What's the pattern? Yeah, so the maximum number of vertices is equal to n minus 1, where n is the degree of the polynomial. Is the highest exponent. but we're looking at quadratics. Equations versus quadratic functions. Can anybody guess what the difference is between those two, besides the spelling? A quadratic equation. Okay, I should have gone a little further. The form of a quadratic looks like this. That's what a quadratic looks like. Remember, has to have an x squared. So it has its coefficient. So next thing smaller than x squared is an x to the first. It's got to have it. And then we have no x's. Also, we'll go through a little further. For a cubic, it would look like this. What kind of equations do we deal with in chapter 1? Linear. So in linear equations, we had ax plus b, if we're using the same coefficients here. In linear equation, what's the degree of a linear equation? What's the degree of a quadratic equation? What's the degree of a cubic equation? Does everybody know what a degree, how to find a degree of an equation? The degree of an equation is simply the highest exponent. We know the degree tells us if the degree is 2, then we know we only have one vertex. If the degree is 3, we have 2 vertices. If the degree is 1, how many vertices do we have? None, because it's a straight line. Okay, so that tells us about vertices. Now we look at something else. Look at the number of terms in our equation. In a linear equation, how many terms do we have? In a quadratic equation, how many terms do we have? In a cubic, we have. So what does that tell us? The number of terms in a polynomial is equal to n plus 1. Now, whether we use them all or not, that's another story. It just tells us that's how many we have. I could even put the maximum number of terms is n plus 1. All right, so let's go back to this before we go any further. So a quadratic equation has this form. Ax squared plus bx plus c, it equals 0. So whenever we talk about quadratic equations, it has to be equal to 0. So move everything over to one side. This is also called the standard form. Now, the difference between quadratic equations and quadratic functions, a quadratic function looks like this. So what's the difference? An equation, because it's an equation, it has to equal something. Has to equal something. It equals zero in this case. We set it up equals zero. A function, it simply has to equal some function. And it doesn't equal anything until we put a next value in there. So when we solve these, when you solve quadratic functions, try to use abbreviations as much as you can to save time taking notes. When you solve them, what are you looking for? Well, yeah, we are going to find x, but what does the x represent? The answer will come from here. And if you remember what we did talk about in chapter 1. Are these the same? So what we have here is f of x is equal to 0. What does f of x represent? The y values. So when you set y equal to 0, what do you find? From chapter 1. What do you find when you set y equal to 0? This is our first step. What have you just found? Very good. Not the it's the y-intercept or x-intercept? The y-intercept is always the constant. The y-intercepts are always the constant number. So when we're solving quadratic, when we're looking for a solution, we're looking for the x-intercepts. Okay, so how do we do that? Well, we take the quadratic equation, set it equals 0, solve for x. That gives us our x-intercepts. Three methods to solve quadratic formulas or functions. We have three methods. The first method is by factoring. The second method is by completing the square. And the third is the quadratic formula. There's not one method that's better than the other. It's just whatever is easiest at that point to solve what you're looking for. To use these, we have two principles. Principles for solving quadratic equations. And they're pretty much common sense. The first principle, it's called the zero product principle. The zero product principle tells us this. If I have two numbers, X and Y, and I multiply them and they equal zero, what has to be true? One of them? Yeah, it's true. Can they both be zero? Which one then is equal to zero? You're right, since we don't know which one, you're absolutely correct. Zero times anything is zero. But since we don't know which one is zero, then we set them both equal to zero and solve. That's the zero product principle. Since the equation equals zero, then we take everything that multiplies and set that and then see which one actually it is. For example, if I gave you this, what would my x's be to make those equal to zero? Here, because it's an equation, equations you solve. How would you solve that? Does that look like this? Did I ever tell you what X and Y were? X and Y can be anything. They can be equations, they can be numbers, they can be letters, they can be buildings, they can be pictures. I never defined what those are. I just said X, any two things multiplied together, take them equal to zero. So I take both of these and I set them both equal to zero. And I solve. I'm solving for X. So X is equal to -3, X is equal to +5. Those are my solutions. On a graph, those are my x-intercepts. The locations are -3, 0, 5, 0. These are my x-intercepts. Now, how do I know these are my x-intercepts? These are my zeros. Why are they called zeros? If I took 5 and plugged it inside this equation, what would happen? X plus 3 times x minus 5. If I set x equals 5, what's the equation going to equal? 0. That's why this is a 0. Because if I plug it in the equation equals 0. You see the connections I'm putting here. So a solution is the same thing as an x-intercept, is the same thing as a 0. The 0 is the value of the x that makes the whole thing equal 0. That's the zero product principle. But the problem is we have to get this far first. We have to take our equations, what we would have started off with. We would have started off with something like this. We can't do anything with that right now. So our first step is we have to factor it out into its binomial stages. And then we take them as set equals 0. That's the first thing. The next thing next property or the next principle is the principle of square roots. What the principle of square roots tells us is if x squared equals any number. Now that we've learned complex numbers, it can be positive or negative or 0. When we say solve, we mean solve for x, not x squared. We're solving for x. So how do we get x by itself? You square root both sides. The square root and the square cancel each other out. And I'll show you why that is in a second. So this becomes x. Now, whenever you take a square root of a number that's squared, whenever you take a square root of a number that's squared, always put a plus or minus in front of the answer. That's what the principle of square roots are. If x squared equals 4, solve for x. So I square root both sides. The x and x squared cancel, or square root cancel. Square root of 4 is 2. But the answer is plus or minus 2. Because if x equals 2, then x squared equals 4 is a true statement. 2 squared equals 4. So 4 equals 4. That checks. If x equals negative 2, x squared also equals 4. We put negative 2 squared equals 4. Negative 2 squared is 4 equals 4. That works. So that's the reason. This degree also tells us the number of solutions. So think of what the degree tells us. It tells us how many x-intercepts we'll have. It tells us the number of solutions we can have. It tells us the direction of the curve. What's 3 squared? What's negative 3 squared?
-9,
Why?
because it only belongs to -3.
Order of operations. Exponents, because what negative 3 means is -1 times 3. This is multiplication. This is exponents. So order of operations says do exponents first. So this is -9. Negative 3 squared is is positive 9, because what this says is negative 3 times negative 3. Negative times negative is a positive. 3 times 3 is 9. This one's going to be a negative 9. Because what this one tells us is there's a negative sign. This is negative 3 times negative 3. The negative is front. Negative times negative is a positive. 3 times 3 is 9. So the answer is negative 9. You have to be very careful of where the exponent is and what the base number is all about. Is it in parentheses? If not, then the negative does not belong to the exponent. When we factor, there are two types of factoring we'll deal with. Binomial and trinomial equations. What's the difference between binomial and trinomial? One's 2 terms, yeah, one's 3 terms, right? So let's look at binomials first. Now, in binomials, we have 2 possibilities. Only one term has an x, or both terms have x's. This is what this means. X squared minus 4 equals 0, or x squared minus 4x equals 0. So again, we're dealing with binomials. We only have 2 terms. If only one term has an x, how do we solve it? What are we supposed to get by itself? What are we solving for? The x. So get the x by itself. What do you have to get rid of? The 4. How do you get rid of the 4? Add 4 to both sides. So x squared equals 4. Now solve for x. How do we solve for x? What do we do now? Yeah, the square root principle. So we get rid of the square root. So x is equal to what?
Plus or minus 2.
Plus or minus 2. That's my solution. And always check your answers. You check your answers. So x squared minus 4 equals 0. If x equals 2, we have 2 squared minus 4 equals 0. 4 minus 4 equals 0. That works. If x equals negative 2, then we have negative 2 squared minus 4 equals 0. So they both work. You notice what I did with the second one. Whenever you plug in the variables inside there, if you have a negative variable and you plug it in the equation, put it in parentheses. Because this whole number is squared. Make sure you put it in parentheses. So if only one term has an x, then we will use the zero product principle. If both terms have x's, in other words, if there are two terms with two x's, how do we solve this one? We solve this one by factoring. What do they have in common? They both have an x in common. I take out the x. What do I have left? If I take out one x, what do I have left? Because this one used to have two x's, I took away one, only has one x. This one used to be 4x, I took out the x, I just have a 4. Now I have two terms multiplied together to give you 0. So what do I do now? I use a zero product principle. I take both of these terms and set them equal to 0. The zero product principle. So one of my solutions is already done. It's x equals 0. And the other one is x equals 4. This is the check your answer part. CYA. So our equation is x squared minus 4 equals 0. If x equals 0, 0 squared, 4x, minus 4 times 0 equals 0. 0 squared is what? 4 times 0 is 0 minus 0 is 0. So that one works. So 0 is a solution. And the next one, if x equals 4, I got 4 squared minus 4 times 4. Does that equal 0? 4 squared is 16. Minus 4 times 4 is 16. 16 minus 16 is 0, and that works. What do y'all think? Binomials. Only two possibilities. Trinomials are another story. We'll cover that next week. Trinomials, there are a lot of steps. There are two separate rules we have to do, a lot of steps, and we'll cover that next week.